We've got quite a lot of tropical birdsong on the background of this. That's just what goes on in my head. I jump out of aircraft from time to time in the middle of describing things. I will try and clean up the audio as much as possible. I have got rid of most of my interjections, which is why it jumps around a lot. This is a conspiracy theory, but it's not a Mason bashing thing. It's nothing to do with hiding the Ark of the Covenant in Newfoundland or other things akin to Jesus visiting America. It's not intended to be anti-Masonic. I can imagine American Masons telling me that Freemasonry started in 1717. No, it didn't. There are 3 fairly long lectures, 20 minutes plus, one on the Abbey and 2 on the Sonnets. They're quite a mouthful. I'm not expecting very many people to go through them, but if you're serious about this, I'd like you to go and look at this, please. I have 2 geometries to show you here. This is Westminster Abbey, Poets' Corner, and this is a notable publication. They both hold quite elaborate geometries. The Abbey, it turns out that every monument placed there in the 17th and 18th centuries, most of them are in the 18th, but there's 2 in the 17th, and all of them are geometrically related to the centre of the Shakespeare monument. All the ones in the 18th century are related by one of 2 triangles, either a 3-4-5 triangle in the horizontal or vertical plane, with Shakespeare at the 3-5 end of that in each case, or via a 30-60-90 with Shakespeare at the 30 end of a half equilateral 30-60-90 triangle. And then the only other 2 are at angles of 17 and 40 degrees. One is looking down at 17 and the other is at an angle of 40. And then we're left with this kind of question mark here as to what's under here. You've probably got problems with this to begin with, because it's obviously it's kicking a hole in this, but what comes next, you're not going to believe any of this. There is a highly elaborate geometry on here which I shall explain in some detail without the page. So all of this is geometrically consistent, and yet it's kind of doing all this stuff on the page. And it really doesn't matter how much I go on about that. This is essentially Alexander Wall's work. I've done work mimicking the approach of Queensland University in disputing the Bible codes, because you can turn that kind of stuff inside out and demonstrate that you will not get this level of density. I mean, this is an entropy paradox. This is not plain text. It's John Dee text. Where we're going with this is that these people, the Freemasons, these people have taken this guy, Edward de Vere, and he's responsible for this, I'm afraid, and they've made that very clear repeatedly, again and again and again. They've gone and buried him under here, in the middle of Westminster Abbey. Fancy that. Poets' Corner. This photograph is just over 100 years old. In the era that I'm looking at, which is up to 1800, this wall was blank apart from Shakespeare when it was put up. Now, I don't have to argue with you about who put the wall up, as that's universally agreed to have been the Freemasons, and I think they'd probably put it up on June the 24th, but it was in 1723 in the Gregorian calendar. The rest of the monuments here, so we can ignore these, but these 2 here, and there are 7 round the back that are connected to this, and indeed the monument itself. I do have to argue with you as to whether or not they're the Masons. The official line on, as I said, the monument itself is that the Freemasons put the wall up and then ran out of money before putting it up in March the 11th of 1740 in the Julian, and we'll go through why it is 1740 and not 1741. The reason that they've picked that date is because it's 2 weeks before New Year in the Julian, and hence Easter. There's quite an Easter element to this. So let's just address this. The Freemasons have no money. Almost all of the monuments in Poets' Corner in the era were designed by William Kent, and during the exact time of the erection of Shakespeare, William Kent was in the employ of Field Marshal Richard Temple, 1st Viscount Cobham, who is responsible for snow here. This thing in the middle in particular is exceptionally masonic-y. This is another of Kent's creations which War alerted us to. He does like his geometry, does his own Mr. Kent. Now this is round the back of Shakespeare's monument, and this will have been drawn before 1800, I think. And you can see all the railings. Here's Dryden. This is Chaucer, who's not involved in the geometry, but is involved in the story at some stage. This is Phillips, and this is Drayton. You can see that Spencer's got railings around him. Gray doesn't. Now, Shakespeare had 17 railings around him, and while he's in a sort of a Cairo stance, that is quite visibly a 4, actually, I would suggest, and that's an X. On that drawing. So we've got another 1740, 4 times 10. Now I've had to write on there because you can't really see it very well, P. Shoemakers MD CC XL, which of course is 1740 in Roman numerals. I don't believe Shoemakers would have done that to the, I think that was added by somebody else. This didn't appear until Queen Elizabeth II's Silver Jubilee. Now there are 17 of these embellishments, whatever they're called, notches on the slope, and 40 across the bottom, and there should obviously be at least 20 on a slope. Well, that does end up at the same point. So that's obviously deliberate. So we have another 1740. And then he's pointing to temples, but we've got 17 characters across the top, and then 4 T's. Yeah, that's another 1740. Yes, it is. I want to now demonstrate to you that not just that wall, which is, we know was made by the Masons, but every poet monument up to 1800 was put here by the Masons. And the reason I know that is because they're all geometrically aligned. The ones at the front are in these Pythagorean triangles, and the ones at the back are in 30, 60, 90s, apart from the 2 originals, which are at 17 and 40 degrees. And I'll go through these in detail now. Edmund Spenser was erected in 1620, the first after Chaucer, and I believe he is at 40 degrees to the centre of Shakespeare from the first of the monuments. And I also think that it might be 40 degrees across here. I'll put a question mark. Need to be careful about mucking around with photographs. But Michael Drayton in 1631 is looking down at 17 degrees. I thought it was 18 degrees because that's got a nice geometrical ring to it. But in retrospect, I suggest that that's 17. John Phillips then turns up at the beginning of the 18th century, and there is a black line there. I've coloured it in red, but there's a crease. These are 2 pages, and I believe from that centre line it is exactly 60 degrees to Shakespeare. Now there's just a thing about how they put it in here. I'll just flip that around. I mean, what are you playing at, Masons? I mean, you could have flooded into there. What's that all about? Medieval cathedral. This is York Rite, which is really an American thing, as I understand it. So I just wanted to give you some Freemasonry symbols and some triangles on this nice Templar cross. I now need to introduce you to the Hans Holbein of 18th century Westminster Abbey. This is John Michael Risbach, and he's responsible for all of these. These 2 are Stanhope and Newton, which are twin, near the choir, I think it is. And then these 5 are all Risbach, and they are all aligned to the monuments. Well done, Michael. So let's just go through these. There's 3 60-90s. Johnson is staring down at 60 degrees. Got that symbol for you again. And then Gray is also at 60 degrees, but we've clunked a few things about Gray. This is another Freemason symbol, lots more triangles. So what have we found out about Gray? Well, I knew that there was a spear here, that's what I've been claiming, and that seemed to be a tangent to this disc.
Well, I've now realised that the perimeter of the disc, if I multiply that black line by pi, I get this line. Moreover, that black line, I swear to you, was drawn by calculating the midpoint of this red line. Here's Polyolbion, which is again universally regarded as the root of our Britannia legend, myth, usage. There's a bit more to this. Milton, this is, was put there by Risbach, 1737. Then John Bacon the Elder has built grey and the darker marble. I notice that we are pointing at the foot of a pentagram, but I realise that this circle at the top and the line here do fit with, this is a masonic design, or putting a circle and a triangle and a square together, and there is hexagonality in here. This appears to be 60 degrees across the face of this tablet. So again, it's just a photograph, and I've had to muck around to glue the bottom on. There isn't a nice photograph like that, but I do suggest that John Bacon the Elder has framed Milton here, Risbach's Milton, rather beautifully. Now, Risbach, having constructed all these monuments, there is no way that this has just been plonked there willy-nilly, is it? It is geometrically aligned on its own. I suspect that this is the 34-degree line, and this is the 30s, I will show you. Let's go around the front, and here's John Gay, and he's at the apex of a 3-4-5 triangle. Just go back to here. Gay is here, and this is a 3-4-5. That red line there is the apex of our 3-4-5. And we have Roe. Charlotte is looking through her father Nicholas, through his eyes, straight down onto the centre of the monument. But as you can see, Roe is festooned with Pythagorean triplets. I need to be careful about these ones at the bottom. I believe that she's in the horizontal plane. This block is a 15-8-17. She's also, her arm is at 15-8-17, but the book is at a 3-4-5, and in fact that line is a 3-4-5 as well, from her toes here along that. So that's rather fun, isn't it? And then moreover, the vertical through row is on a 5-12-13 and horizontal. While Roe and Gay have been moved, I understand that these frescoes themselves now have been removed, and we could put these back, which would be nice. This is Prior, and I believe Prior was put there when the wall was built. In fact, I think that this was the bottom section of it will have been built before the wall, and then the wall will have been built, and then at some stage, probably a little while after, all this flowery stuff was added on, but they needed to get this up. The green line I've derived here, and I've also derived the yellow line. The yellow line is where that 40-degree line hits a perpendicular from grey, and that appears to do that on that corner here, such as that. If that's correct, in order to illustrate that Prior is indeed focused on the centre of the monument based on these angles, and hence give us a degree of confidence that the rest of this is as described, all I need is the outline of Prior. Now, the Abbey have been exceptionally good. Unfortunately, this is covered in chairs for almost all of the time, other than on a Sunday when they have a congregation on the other side of the wall, and that would be the only time of the week where someone would be able to get at this. Now, ideally, what you should notice, if any of this is valid, is that the corner of the architraving between this bottom bit, this skirting board, and this central part, there's a corner on the architraving at each point. Now, this outer lot should be just the same. It should be concentric with or eccentric to this right? Otherwise it'd be rubbish. Right? If any of this, if they've gone to this level of trouble, they will have done this. So you should notice that the corner of the architrave here at the front appears to be quite acute at about 17 degrees, and this one should be at 18, and then this one should be at 40 degrees, isn't it? So they should, but they should, each of them, they should fan out, and so when you get to this corner, that the corner of that architrave should be pointing at quite a different angle to this one. So you can note that, but what I'd ideally like is to the millimetre profile measurements of prior of both that central section and the outer section, and then all I then need is this distance to here, and I can then predict what this distance is, and indeed where that wall is. I can tell you where that is, and hence where that point should be, etc. Those are most of the monuments. I didn't put Spencer on there because he hasn't got a bust on it. You'll notice there's something circular about most of those. Butler has been mucked around with, so there's nothing circular left on him, but he's been truncated and right. But it's not so much those circles. I just noticed that it's that they've all got a rectangular block of text underneath them, and Shakespeare, I keep telling you, that was added. There's nothing underneath Shakespeare, nothing here, and there really should be. Why is that? Let's just pop over to Stratford-upon-Avon and the funerary monument, which consists of two sections. There's a Latin thing, and then below it there's this block of text which I'd like you to just have a read of. It's Gansed, isn't it? It's not Canst, it's Gansed. And then ask yourself, do you think that's a puzzle? If you don't think that's a puzzle, if you think that's just how they did things in them days, then we have a difference of opinion. Bottom bit's a bit mad. War has some stuff about this as well, but this is the killer. Let me show you what was discovered 10 years ago. Pullian, and as I understand it, we only know one person from Puglia, and that's Nestor. So a Pullian in judgment, or Nestor in judgment, a Socrates in genius, a Maro, which is also Virgil, in art, that buries him, the people mourning, Olympus possesses him. Let's just for a game see if we can work out if that's as it Earth buries him. Maybe these are three people, maybe these refer to three people that he's buried with, and it can't be these three, so it must be allegorical in some way. Some people. So let's see if we can find three people. Deschamps, a notable French poet, referred to Jeff Chaucer as the English Socrates, whose keen insight reveals the soul with reason's guiding light. I don't know if he actually says genius, but he is the English Socrates. That's good enough. Spencer calls himself Virgil. As Virgil sang, so Spencer's lyre inspires. I believe that's from the Fairy Queen. There we go, Spencer on Spencer. I mean, anybody of the era would have known that. And then Ben Jonson, who is widely regarded to have been responsible for this stuff, Beaumont, whose judicious wit and measured art. The thing about these three that's notable is that at the time of chiselling of this, there are only, or were only, three poets buried in Westminster Abbey. I'm sure you can guess who they are: Chaucer, Spencer and Beaumont. And the funerary monument is batshit crazy. I have a further geometry for you now. This one, it's so complex that you're not going to believe it. What I want you to do again is, before we start looking at this, is just to read the stuff on the right, which I've straightened up and expanded just so that we can see it better. And again, I'd just like you to read that. I won't bother doing it for you. And just ask yourself this question: do you think that's plain text? It's all in caps. Well, this is a printed page. What are all these full stops? People write dissertations trying to wriggle out of what begetter could mean and how that would somehow magically unlock the rest of the page. This is the Folger instance of this publication. There are only 13 copies of this in existence that we are aware of. Of those, there are only 4 of the William Astleys. There's a subsequent version, and it's quite obviously it must have been subsequent, that for John Wright, and they will break the geometry at the bottom. However, all 13 copies have a break in the P, a break in the R, a blob above the N. That gouge is on all of them. The gouge on that N, that is quite deliberate. 2 blank lines, of course. A huge full stop, and on some of them that stop gets really big. It gets much even bigger, huge, the size of a letter O almost. And then this strange taurine T. They all have that. And the upper part of the geometry generally fits. I've noticed from the measurements that I've made that Sonnets seems to jiggle up and down, but really there is only one copy where the finer details of this that I needed to unlock it exist. If you want to depart now on those grounds, then fair enough, because you're not going to believe the next bit. So it's all that and all that as well, and there's actually more. These are just 6 pieces of artwork that I put together to illustrate this. I'm now going to inflict upon you a geometry lesson without that behind it, to try and convince you of the integrity of these diagrams. And once you get bored, you can zoom on and come back here, and I'll explain to you what is meant in these diagrams. Right, but this is by far the more complex of these 2 geometries, and the way I'm going to describe it is that at the core of it is this design, which was illustrated by Albrecht Dürer, not in Melancholia, his more famous and heavyweight publication, in an arts and crafts book, the Pythagorean, which is fairly simple for the width of this line, is not the same as the height, which is slightly more complex and isn't going to cancel out. He would have known that. He definitely knew that, and has had this again, but would have blinked and known that. Now it connects the hexagram with the pentagram. It's the hexagram of the macroverse, and this is the microverse involving knowledge, the pentagon being a symbol of knowledge. Let's see how we construct that. We're going to take a 51-degree isosceles triangle of base length 1 and mount an inverted equilateral triangle with its centre at the apex here of the 51-degree pyramid. And inside that equilateral triangle, we're going to drop our hexapentagon thing in the middle as such. I call that a golden gnomon. You can call it a wide-mouthed golden triangle or the other golden triangle. What we then do is, if you draw 2 squares from this top, so down from this line, just draw two squares of side length half of that length, and then inside that draw quadrants, so that's a quarter of the length. And you'll notice that this circle, which obviously has 2 side lengths of the hexagon length, appears to terminate, round about exactly, it's a little bit lower than this quadrant here. Now there's actually a mark on the page here and here, to rub it in. But the point about this is that once you've clunked it, you then discover that the hexagon is approximately the same length, the perimeter of the hexagon is the same length as this one here, and this one here. All these are the same, definitively. But it's better than that, because we then take a pentagram, side length 1, invert it with its apex at the midpoint of our originating baseline, and the bottom 4 vertices of our hexagram actually touch. They're just a little bit over each of them. But within the resolution of that page, you see, they're not actually pointing out along the bottom. It's the baseline of the hexagon is slightly below that. Now, I've bung phi on there a lot, just to remind you that the ratio between that side and that side is phi, because that's going to come up shortly. There's one bit of maths and it's coming up. There's a few more things to go on with that square up there, but they're essentially to do with integration with a circle at the bottom which generates this lower line. And so these two input points, this big point here, which is the origin of the entire diagram, and then the secondary point here, those are your only two input points. They're round about 47.7. So if you draw something at 47.7, this will round about work. And from this point here, we then draw a tangent, and where the red dot is, we don't know where the red dot is yet, but where the red dot is, we draw a horizontal line, and where it terminates on the circle that we drew, that defines the base of our 51-degree pyramid, and hence the rest of the diagram. But we don't know where this thing ends yet, so we're going to do that by drawing a Pythagorean 3, 4, 5 triangle. As such, its hypotenuse as the diameter, and we're going to draw a line through another red dot, which I've drawn a bit too big really, that's a specific point, and where that intersects the tangent, where we're going to terminate this line, and then we're off. We've got the baseline. Okay, get ready. We need these two triangles, this red triangle and this green triangle. And the red triangle has an angle θ1 at the origin point here, which is equal to inverse tan of 1 over pi. If I put a circle around that short side, its perimeter will be the same as the length of the long side, if you want a geometric kind of thing. Then this lower side is inverse sine of 3 over 5 phi. The thing about that is that the angle of a 3, 4, 5 triangle, this angle up here, the sine of that is obviously going to be 3 over 5. And this blue line forms a golden ratio with this green line. Therefore, θ2 is equal to inverse sine of 3 over 5 phi. And there's this beautiful quote, which I previously thought was 1612. It's not, it's 1596. Geometry has two great treasures. One is the theorem of Pythagoras. The other is the division of the line into an extreme and mean ratio, which is what we called the golden ratio. And the fun thing about that is if you stick that into a search engine and page down a little bit, you'll start getting Freemasons, American ones, the very chatty American ones. They've got lots of websites. That is what maths was in the Elizabethan era when Freemasonry emerged. I've now managed to define the red dot as where a line between the right angular vertices of these two triangles crosses a horizontal from the G. Right, sort of, and that's the best that I can do. I'm really sorry. So let's just rub all that out. And we've got this nice simple semicircle, and then there's this little line up here, and then that defines the lower rule. Right? Isn't that pretty? And then what happens is that as on top of generating the rule, we then integrate time and again in these bizarre coincidences. So draw vertical from the corner of this phi triangle, and it just goes bang on to this vertex here, this point here, and then there's a corroborating mark here, and there's a little dot here. That's the first of I think there are 8 in total. This is the next one. Here's our lovely pentagram, and if we take my golden gnomon shape here from it and flip it down here, then the vertex of this thing appears to be on the circle, and of course it's not perfectly on the circle, but it's inside the eye of a number 6, a beautifully round eye of a number 6 that's obviously on the bang on centre line of the diagram. Golly gosh. And this golden triangle within it again is corroborated. From the origin, if we draw a 21-degree line from the vertical, 69 from the horizontal, I've drawn, and where that terminates on the great equilateral triangle up here, we will take that as the right angle corner of an extended half equilateral triangle here, 30, 60, 90, and blow me down with a feather, its vertex, when you do that, is on there, is on the circle, again well within a millimetre, with a 30 centimetre width page, I beg your pardon. The significance of 21 is that it was the declination of, I thought it was the brightest, it's not, I'll come back to that, but it's the last supernova, and it might have been the longest lasting in the sky. This circle generates two lines, generates this baseline of the pyramid, this lower line here, but it also generates this line that has a half square 45 degree, 90, 45 degree triangle. Now this upper rule, it's one of the two rules on the page of course, this upper rule is defined as running from the corner of the pi triangle to where this line intersects it, and this line is a chord, it's a parallel line to this tangent, and it runs from the corner of the phi triangle. So a parallel line to our lower baseline defining line, which was complicated to do, but this is just parallel to that, and where it intersects a horizontal from the pi triangle, that defines our upper rule. And that will be just a little tiny bit in from this, but hardly at all. You'll notice that this circle bends in, and I put it to you that you noticed that these two lines are noticeably different lengths on the page. Only just, obviously, but they are visibly different. As a result of this being nudged in, then unfortunately our apex can't be on this line, which we want it to be, but it does go perfectly through, to the micron, through that cross point there, and so that this half square is flush with this diamond that I've just plonked in there. This is fairly scary, I suppose. This is D's signature, and what we do here is we define another half square from that point that's terminated on this chord line parallel to this tangent line that defines the upper rule. We define this half equilateral as terminating on that, and then reflect it round, and then we've got an equilateral triangle. This red triangle is defined as originating its left vertex at the corner of the phi triangle, which is also where this line originates, the parallel line to the tangent line originates from the phi triangle. Well, that red triangle does, and it's an equilateral triangle, and it runs, it's also defined as running through that dot there, so it's not surprising that it does that, but it does coincidentally, it's vertically coincident with the half square here. But then we define another half square line, if you like, a 45 degree line here, and it is defined as terminating on this red baseline, but again, it's inside the pixel. It's well inside the pixel. A pixel is a 1/7 of a millimetre. And then that bounces up to a horizontal from the right angle corner of the 3-4-5 triangle. The destination of this is actually this Cairo, discovered by War nearly 10 years ago. I would like to give you that at the end, but I need to define this dot here in the explanation, which is defined as running from the 9 dot through the centre point, and then it just turns out that it runs up the side of a P, which we are obviously going to substitute as a rho. And then this other side of the Cairo is just a reflection about the x-axis, or y-axis for that matter, obviously, at that point, at the centre point. So there we go. So there's this very important red dot, because that same red dot I'm then going to use. I'm going to draw a 20 degree line from the vertical, so 70, and I'm going to terminate it on this vertical, but as a result, it's going to turn up just over a millimetre north of there, but it's slap bang in the middle of the letter. But it also coincidentally goes essentially straight through this vertex here. There's a comet-shaped full stop right on that point. Now, this red triangle is defined as where this blue saltire, which is defined as originating at that point on these two squares, which come from you've seen where the squares come from. So you draw that blue line up to the elevation of the pentagrams and then reflect it across there. Now that's the ugliest part of all this. Only two other ways that I can define that: from the south going up, but from that point I can draw a 23-degree line bang on to this point, and that 23-degree line I think means Venus, but it was called line 23 for a good 6 months until I realised that these were stars. And Venus does have a declination of 23 degrees as an evening star. Now, from that point, we cast out a golden triangle and terminate it on a horizontal at the apex of our 51-degree pyramid. And it just so happens to do that. But it does something else as well, is that when you extend this side of it down, it makes this little red golden triangle there, with the baseline and the inner golden triangle of our golden gnomon, same size as this. And it's like, well, yeah, well, of course it does. I mean, there are many ways in which we can derive, obviously endless ways, that we can derive golden triangles as such. It's just I haven't shown you the page yet. That is right inside a very important letter O within the page, and so I've got this comet, etc., and this is as a full stop, etc. There's one other thing now, which is that I'm now going to drop a dodecagon in those two squares as such. I've got a point here, which is exactly 15 degrees from here, and I'm afraid that's almost all the justification. Now, from this, I'm going to draw from that point where the hexagon cuts that square. I'm going to draw 49 degrees, and I'm just going to terminate it up here on what is actually a letter, and I've got a 48 degree, bang on 48 degree line. Right now, these are integer degrees, and the trick is that, we're doing astronomy, right? We've worked out that these are stars, so let's go down the library and see all the astronomy books. So there is the Vere catalogue that was published just a couple of years earlier, and that is to this day is the definitive list of navigable stars. I'll put columns on there, and I'm going to do that via some letters. Then that starts, and then what we're going to do is we're going to wrap a triple tau, this 3T thing, around those two squares as such, and draw lines from the dodecagon to extrapolate it. And that is quite a profound symbol. If you take this triangle, the equilateral triangle, which is extremely masonry, okay, right, but I've got the triple tau is exclusively masonry, if you like. And then I've got this dodecagon, which I'm going to substitute for a circle. It's quite circular, isn't it? And of course, as any mason will now know, if I invert that triangle and then shrink the triple tau to fit inside there. And that is the symbol for Royal Arch Freemasonry, which the Masons claim turned up in the middle of the 18th century, around about 1750. I can't claim that symbol as is on there, but the components are. And the gist of what I'm getting to in terms of the emergence of Freemasonry is they didn't evolve from an English working men's club. They didn't evolve from a builders' union. They were a product of the intellectual explosion of the Renaissance in England. What I'm now going to do is drop in a recording that I'd made 2 years ago about this geometry. What I've just done is given you, the white background stuff. We begin with Albert Dürer's method of deriving a pentagon from a hexagon and the huge gouge present on all extant copies of the Sonnets. The 5 S's are coincident with an equilateral triangle of the same side length as the lower anonymous rule in the middle of the page. When calculated accurately, the right apex of the triangle is on the square dot in the right S, and the right side of the triangle slices straight through a dot on the first of 3 lowercase i's on the page in imprinted. The 3 central S's form a golden gnomon, a 36, 36, 180 degree triangle, cut from the equilateral triangle. Within that there is necessarily a pentagon, below which we can hang a hexagon, just as in Dürer's diagram. Dürer's 45 degree diagonal crosshairs between the outer vertices of the pentagon and the hexagon perfectly intersect the defective N in the centre of the page. The exact centre of this great triangle is on the right serif at the foot of the central N. This point forms the apex of a 51 degrees flat isosceles triangle, using the lower anonymous rule as a base. 51 degrees is the integer component of the slope of Khufu's pyramid in Giza. This value had been public domain information for 2 millennia by the time the sonnets were published. From the midpoint of this lower rule, there exists an inverted pentagram of the same side length as the triangle and the base of the pyramid. It is perfectly coincident with the left A. The inner sides of the left A form a perfect golden triangle. The right A is different, as we shall see later. Inside this pentagram is contained a pentagon. This pentagon almost perfectly bounds the hexagon we derived earlier along its lower side and its 2 outer vertices. The pentagram clips the T of sonnets at a point that 3 lines will eventually meet. The right foot of this inverted pentagram is on the R at a point which appears to have a raptor beak fashioned onto it. The falcon depicts Horus in Egyptian mythology. The right side might signify an ibis. The upper diagram can thus be generated just from the lower rule, which will derive the centre and side length of the great equilateral triangle and the apex and side length of the great pentagram. There is a guide marker to the right of sonnets on its centre line. It is exactly 1/12 of the length of the baseline from its end. Its reflection across the common right vertex of the hexapentagon is almost exactly 1/4 from the opposite side. This illustrates that the perimeter of the hexagon is almost exactly that of the side length of the triangle, pentagon and pyramid base. There is a vertical from this node forming a sacred Tau cross. It is corroborated by a capital I which eclipsed and borders in the same fashion as the geometry works throughout the page, and is terminated by the dot next to 1609. The centre line of never before imprinted is exactly half the width of the Great Pyramid and side length of the equilateral triangle below the strike-through of Shakespeares. As such, we can form 2 squares coincident with the upper side and vertices of the Great Triangle that have their lower sides through the centre of never before. On the right quadrant, the 2 diagonals will clip the serifs of the T, in particular the wonky left bar at exactly the same point that the Great Pentagram clips it. The triple Tau is one of the most prominent symbols in Freemasonry and forms the centre of the symbol for Royal Arch Freemasonry. It is comprised of a T above an H and represents the phrase Templum Hierosolymi, Solomon's Temple. To convert 2 squares into a triple Tau, we can perform 2 operations. Firstly, cut off the top left and right corners with a 45-degree cut, then reflecting the remaining left and right half sections to make the triple Tau. There is a perfectly formed mark on the centre of Shakespeares next to the R. It is at precisely 15 degrees from the vertical drawn from the bottom right corner of the right square. If we extrapolate that, which can be illustrated by extending the edges of a dodecagon as such, we can draw out our triple Tau. The left end of the upper T of the triple Tau terminates on the stem of the H. It is actually 1 mm inside the stem according to the predicted geometry. Within the triple tau is a concealed fourth T. This is a core element of the cryptography around Vere, who is regarded as the fourth T. This can be represented in numerous ways, including 4T, 4-0, and even 4 O's, as concludes Hamlet. Within the inverted pentagram that bounds the hexagon of the vesicapiscus, to the left we can derive a golden triangle as such, which is corroborated by the A. The predicted geometry runs up the inside of both legs of the A. Our triple tau cuts this A along its bar, intersecting both nodes of the A. The golden triangle is almost perfectly coincident with the right node of the hexagon, and their bases are almost horizontally coincident. Hiram Abiff was given a golden hammer, symbolised by the temple T of the triple tau, and a golden triangle symbolised by the A. I will go on to describe a star chart which will identify the right stem of the H and the stem of the K as the two pillars of the Temple of Solomon. The central node of the triple tau, between the O and R of before, will be used subsequently to derive several further elements. At the bottom of the page there is a circle first discussed by Alan Green in 2016. It consists of 3 triangles with specific trigonometric values for their angles. They reflect this quote from Kepler, published 3 years later. The 3 triangles have angles of inverse tangent of pi, such that its middle side is the length of the circumference of a circle of diameter equal to the short side. Then the inverse tangent of 3/4, or a 3-4-5 triangle. And finally, the last triangle has a short side which forms a golden ratio with the short side of the 3-4-5 triangle. It has an angle at the imprinted dot of inverse sine of 3/5 phi. The right angle of the pi triangle is approximately at the right end of the upper anonymous rule. The right angle of the 3-4-5 triangle is close to the dot after Aspley. This dot is at the same angle as the imprinted dot and is truncated. Extrapolating the apex of the pyramid brings it close to the predicted location of the 3-4-5 right angle triangle. But we are still 1 millimetre to the left. This anomaly is consistent throughout the setting of Aspley. Everything is 1 millimetre to the left of where the model predicts it to be. I believe this is due to triangulation with elements other than the circle in the upper part of the page. The corner of the third phi triangle is at the 9 dot, the dot next to 1609. This dot has a hexagon cut onto its right side, which is sympathetic with several subsequent components. There is again a correction required of less than half a full stop, which I will discuss later. The page has been set using triangulation with points further up the page. It has not been set using compasses at the centre of the circle we are describing. The line from the corner of the phi triangle to the imprinted dot runs perfectly along the back of the second T of TT. We now need to draw 5 construction lines that define several intermediate points to describe the endpoints of our 2 anonymous horizontal rules. Firstly, there is a horizontal line from the centre of the spot next to the G. This perfectly cuts the centre of the 2 dots next to the 2 T's, and we will terminate it on the circle. There is then a line from the corner of the pi triangle at the top to the corner of the phi triangle at the bottom. It cuts the horizontal line we have just drawn at the dot after the second T. This dot has a golden gnome on a 36-36-108 degree triangle cut onto it, and its apex is pointing at 30 degrees to the vertical. It is pointing at the kink in the A of Aspley. We now need to calculate the intersection of 2 lines to determine the left side of our lower anonymous rule. The first is a tangent to the circle from the spot next to the G, hence a line perpendicular to the diameter from G to imprinted. The second is a line drawn from the predicted corner of the 3-4-5 triangle through the point we have just derived for the golden gnomon-shaped dot to the second T. Where these 2 lines intersect is the left side of the lower rule. Where a horizontal from this point intersects the right side of the circle gives the right end of the lower anonymous rule. These 2 points define the bottom vertices of the Great Pyramid and hence the rest of the diagram. In principle, the entire model can be drawn with just 2 input points of the G and imprinted dots. There is now a 5th line, a chord which is parallel to the tangent at G and is drawn from the corner of the phi triangle, the 9 dot. The line cuts a horizontal drawn from the right side of the upper rule as described by the pi triangle. This construction line runs through a strange dot placed above and slightly to the left of the A of at London. It has been very precisely placed there and is intersected by a total of 5 other lines. There are numerous further restrictions on the geometry beyond accurately predicting the anonymous rules and hence the basis of the upper diagram. The circle should be such that a golden gnomon, a 36, 36, 108 degree triangle, formed with its long side as the lower anonymous rule, should have its apex coincident with the circle. The perfectly round eye of the 6 of 1609 is exactly at this point. Furthermore, the dot of the second eye of William has a line cut through a golden rectangle. The geometry predicts this line with eerie precision. Within this golden gnomon exists a golden triangle, corroborated by the modified y and the slope of the w of William and the angle of the first t, all being at 18 degrees from the vertical and coincident with the 6. The right outside of the w is at 40 degrees from the apex of the gnomon. There is then the tau cross of the vesica piscis diagram above. It is coincident with the 9 dot. There are at least 3 further conditions connecting the upper to the lower diagrams. There are now 3 instances of each of the 3 triangles, equilateral, golden and right-angled isosceles. We already have a great equilateral triangle and also a great golden triangle from the great pentagram. The large right-angled isosceles triangle has its base as the upper anonymous rule we defined with Kepler's circle. It is slightly shorter on either side to the lower rule, that is the base of the Great Pyramid, and it is shorter on the right than the left. A 45-degree line from the right side will cut the Great Equilateral Triangle at exactly the same point it intersects the tiny dot on the eye of imprinted. If we zoom into that dot, we can see it appears to have the bust of an ape-man carved onto it. This 45-degree line continues and it intersects the strike-through of Sonnets, which is the interface between the pentagon and the hexagon, exactly at its midpoint, the midpoint of the entire diagram. The line then continues to the stem of the N, where it is intersected by the opposite 45-degree line from the left side of the upper rule. This apex is also coincident with the midline between Noy before and Shakes, which is 2 mm above the centre line of Sonnets. The second right-angled isosceles is defined as having its apex at the midpoint of the lower anonymous rule, the base of the Great Pyramid. Where a 45-degree line from there hits the construction line from the 9 dot to the left side of the upper rule, we define as the left vertex of this triangle. As you can see, it is exactly on this strange angstrom dot of that A. The reflection of this left vertex lands on the tiny dot fashioned onto the corner of the last N of at London. The diagonal of that N is at approximately 45 degrees. The second equilateral triangle has one side and its right vertex defined as where a 30-degree line from the vertical drawn from the centre of the triple tau intersects the horizontal from G drawn to the left. This occurs at the base of the B of bi, where the bottom serif is rounded off and the top one is a large block square. The right node of this triangle is the dot after the first of the 2 T's. We define this as where a line drawn from the 9 dot to the centre of the diagonal cuts the horizontal. It has a hexagon fashioned onto its lower side. This point and the extension of that line have great further significance. It is one of the 3 stops on that line which are each used multiple times by the geometry. For now, it is just the right vertex of the second equilateral triangle. The apex, formed from a 30-degree line back from the vertical, is almost perfectly above the dot above the A, corroborating this element. We can reflect the line from bi through the triple tau to the R. It will run from the A of Shakes running symmetrically across its right leg and down to the R of R at the bottom. The original line runs from a triangle with A inside it up to the R of R. So we've got sort of 4 A's, 4 R's. I haven't decided what to call this object. The second golden triangle has its base defined as being horizontal and coincident with the apex of the Great Pyramid. Its right vertex is at the intersection of this horizontal and the extension of the golden gnomon of the Vesica Piscis. The 30-degree line from the central node of the triple tau extends upwards and is terminated at the height of the pentagram, which is also coincident with that R. The reflection of that point across the strike-through of Shakes defines the apex of the second golden triangle. There is a square dot at this point, which I believe signifies Venus. The derived left vertex of this triangle is the chocolate drip from the T of Sonnets. The line of the Great Triangle cuts through the S and this triangle at exactly the chocolate drip from the S, and the right vertex is suspiciously close to the comet shape for full stop. If we extend the left side of this triangle down, it will pass through both the O's at the bottom. The upper one is exactly below the O of before. The one of 4, which is also cut by the smaller golden triangle that we found from the golden gnomon at the bottom, forms a tiny golden triangle inside it. Now there are literally hundreds of golden triangles I could derive using the horizontal from any thus far derived node and the pentangular lines we already have, but none of them are going to turn up perfectly inside an O, which will turn out shortly to have enormous significance. The third equilateral triangle is defined as having its left vertex coincident with the 9 dot. This dot has a hexagon fashioned onto its right side. Its right side is defined as being coincident with the golden gnomon at 30-degree shaped stop after the second T. Doing so will produce a vertex which is almost perfectly coincident with the vertex of the second right-angled isosceles above at London. Its right side cuts the swoop of the A at a point with a kink in it. This reveals a 4. There will be 3 more of these. A 45-degree line from the left vertex of the Great Golden Triangle will run perfectly through the middle end of London and intersect the horizontal from the 9 dot at almost exactly the point of the right vertex of the smaller equilateral triangle. This point is the apex of an inverted right-angled isosceles. A 45-degree line from this point, terminated at horizontal through the corner of the 3-4-5 triangle, will almost perfectly coincide with that right angle itself. The horizontal passes through a gap in the flimsy S of Aspley, and its left vertex is on the blobby end of the swoop. We now have 3 equilateral, 3 golden, and 3 right-angled isosceles triangles, all beautifully interconnected. There is now a star chart consisting of 6 lines, each drawn at exact integer degrees. Decimal notation hadn't been devised at this time. Rounding a number by discarding any fractions, in this case the minutes and seconds, was natural. The first line is from the great spot next to the G and signifies SN 1604, Kepler's star. It occurred a few months after De Vere's death, which was in the summer of that year. Any reference to it is conspicuously absent from the works. The spot has a side flattened off. We can see that it appears to be at 21 degrees, assuming it were signifying an integer angle. The G itself is sloped at approximately 21 degrees. An exact 21-degree line from the vertical drawn from the dead centre of the spot next to the G will drill straight through the centre of the claw on the left leg of the second A of Shakespeares. The line will run along the outside of the leg of the A and is terminated on the strike-through at a point just outside the A. A vertical line from this point will now arrow straight through both the point that the pentagram and diagonals of the right quadrant clip the left of the T of Sonnets and the monkey's head on the dot of the I of imprinted. It will then run straight through the gap on the flimsy S of Aspley. From the vertex of the Great Triangle, if we extend the left
side of the triangle down, the line will pass through the centre of the golden gnomon-shaped stop next to the second T, and through the kink on the Aspley swoop, intersecting the vertical line from the A at the top at a point just a millimetre below Kepler's circle. There are two other 30-60-90s above it, which have their 60-degree vertices on the mouth of Athena. They are derived directly from the great equilateral triangle. We can easily derive dozens of 30-60-90s from the existing other equilaterals. These two tessellate nicely, and I think they are to be interpreted as a trinity with the larger one below it. The right angle of this triangle cuts the left leg of the A in the same fashion as the Aspley A is cut, signifying a 4. The next two lines are both drawn from the dot next to the first of the two T's, currently the right apex of the medium equilateral triangle. They signify SN 1572, Tycho star, and C 1577, the Great Comet of 1577. At 63 degrees to the horizontal and to the left is a line signifying SN 1572. The actual declination of Tycho's star is just over 64 degrees. Bra himself measured it at just under. Taking just the degree component leaves 63 degrees dead. There is a square white dot on the bottom of the left S, centred vertically on the letter and within it. Our flat 63-degree line runs well within 1 millimetre of it. In the other direction, an exactly 20-degree line from the vertical will pass straight through the comet-shaped dot after Sonnets. I have terminated this line, as I have Brahe's star line, on the vertical through the S. It arrives within 1 millimetre of the square white dot cut into the rightmost S, and is centred both horizontally and vertically within the letter. In Brahe's own account of the comet, he states that it appeared in the constellation of Capricorn. The right ascension of Capricorn is 20 hours and then some minutes and seconds. I have assumed that we are in this instance to read the hours as degrees, and that this is the right star is Capricorn. The comet dot after Sonnets is now the confluence of the right vertex of the middle golden triangle, the extension of the upper golden gnomon, and the 20-degree Great Comet line. There are now 3 further stars drawn in connection with the square within the vertex diagram at the top. This square runs up the left side of the stem of that N and passes directly through the bauble that lies on top of it. An exactly 23-degree line from the apex of the middle golden triangle and terminated on the square will perfectly locate the centre of the bauble. 23 degrees was the declination of Venus as an evening star in 1609. Venus represented Horus in Egyptian mythology. In the opposite direction, drawn from the intersection of the hexagon and the triple tau as shown, there is a 49-degree line which arrows perfectly through the middle of the first N. The line continues to arrive at the intersection of the triple tau and the Great Golden Triangle on the left node of the A. This marks the third 4 indicated from the 3 major capital A's. There is a hidden fourth. The line continues to point at a small square dot, perfectly positioned to fit with the behaviour of the 4 previous marks denoting stars, and it is at the top of the right stem of the H. In the Bayer catalogue, published just a few years earlier in 1603, there is only one navigable star at 49 degrees. It is Alkide, the leader of the 3 mourning maidens of the beard. The last of the ends already has a line through it. It's the 45-degree diagonal crosshairs of the Vesica Piscis. The upper edge of it is at precisely 48 degrees. If we take the origin of the Vesica Piscis crosshairs on the right vertex of the hexagon and draw at 48 degrees, it will run perfectly along the side of the N and point exactly at a very tiny single pixel dot at the head of the stem of the K. This insignificant mark is nevertheless perfectly positioned and is the largest blemish on this element. There is no star at 48 degrees in Bayer, so we have to use the complement as we already have several times in the star chart. 42 degrees only has one star. It is Arcan, the principal star of the Phoenix, first included in Bayer. A young Elizabeth I is depicted as the Phoenix in Henry VIII.
In Arkham, the Phoenix and Venus, we have a group of 3 feminine stars. We now return to the circle at the bottom. Ward discovered in 2016 that there is a Chi-rho formed from the reflection of the diagonal of the circle and the extension of the line from the 9 dot to the centre of the circle, which we use to determine the location of the first T dot. This line will run up the side of the P of Shakespeares. Within this, with the important T dot at its centre and using the horizontal through G at its bar, is an inverted Petrine cross. It forms one of 3 crosses. We have the Tau cross of the Vescopiscus diagram, and I consider the central cross with Shakespeares as its bar and the centre line of the diagram as its stem as a 3rd cross. The 4 points of the Chi-rho point to a message. Note that the originating diagonal of diagram cuts through the A of at and cuts the serif of the T nicely. At can be taken to represent Aleph and Tav, the first and last letters of the Hebrew alphabet, and what we say as Alpha and the Omega, the beginning and the end. It appears on most Chi-rho instances. Note also that the model has predicted the dot of the A as being slightly to the right. If we move this character that amount to the right to match, the diagonal no longer barges through the A, but will cut it exactly at its right node in a similar but reflected manner to the 3 major capital A's. This A is a hidden 4. At also represents 4T. The chi of the Chi-rho can be interpreted as a plus sign. This was devised by Robert Record. D himself popularised this symbol after Record's death in 1558. The 4 points of the chi point to, by G, and then by picking 2 characters at each point, D, E, V, E, R, E, by God and De Vere, the 4th T. Returning to the centre of the Petrine cross, the strange taurine T, the letters before it, and the O that has our tiny golden triangle within it. The string D for T has the O as its centre. It contains the term 4T, the 4th T. The T can be interpreted as a bull and hence an ox. This makes D for ox, which is trivially reversed to read Oxford. Removing that, we can take the remaining L and combine trivially with R and make Earl, and hence, by G again, Earl Oxford, the 4th T. D has signed his diagram in triplicate with a further 4th signature for good measure. Ward discovered the principal delta dot signature formed by the lower arms of the Chi-rho and the bar of the Petrine cross. The huge spot next to the G is at its left vertex, and this triangle can be considered to be a reverse delta dot, a signature D used. The medium equilateral triangle has the angstrom dot of the A at its left vertex, and the small equilateral triangle at the bottom has the semi-hexagonal 9 dot at its vertex. These form a triplicate delta dot. I believe there's actually a 4th inverted and hidden delta dot that is the smaller triangle through Aspley that has the swoop dot at its left vertex. This is a hidden 4th D.
Just this 17 thing. This is the end of the first folio. We've got Astley on the first folio, I noted, and we've got, the centre line will chop the swoop off again. I noted that these outer lines are at 40, and I know I haven't bothered to show you that this outer line here is at 40. I know why all these, because when you zoom into this, they're all a bit jiggly. It's like, why? Well, all these verticals mean something. The A is bracketed by the parallel lines that run along the side of the T, etc. The outer line of the W is at 40 degrees, and I noted that. Now, this is finer printing than the sonnets. These E's do seem to be 17 degrees. This then gives us a 17 with Alexander's Chi-rho. So I have now added 17-4T, the missing 17-4T, if you like. Now I wanted to give you just an idea on how accurate this thing is, how precise these lines are. There are 3 lowercase letter I's on this page and one capital I. There's two in William, and this is the I of imprinted. Now you'll notice this first I of William is at exactly the 20-degree comet line here, runs along the back of it nicely, and then this is the line of the golden gnomon, and you'll see the apex of the golden gnomon is so close to this circle you can't actually, even on this magnification, it looks as though it's on there. It's of course it isn't, but it's very, very close. Now this line goes through this dot on the second I of William, and that dot has got a line through it at this angle. That line drills straight through that very faint line that's diagonally across that square dot on William. Now this is the half equilateral triangle, the great half equilateral triangle. It would go straight through that kink, and indeed the other lines that go through this are defined by where we defined that dot in the first place, which is nearer there. This line is just coincidentally what happens when you extend the great equilateral triangle. Now this is the I of imprinted. This is a 45-degree line from the major half square that sits on top of the upper rule, and this is the 60-degree line from the great equilateral triangle, and this is the vertical from Kepler's half equilateral, which itself is an extension of the great equilateral. And these three have a triangle of coincidence of under 1/16 of a square millimetre. It might even be under a 32nd, this one. That is a monkey's head, isn't it? That's Homer Simpson. That is Poet Ape. You can't get more regular angles than 45, 60 and 90.
This message on the title page is now repeated. I have said 3 times, I'll say twice, but they're both really good. There's this 6-to-4 ratio. That's also quite an interesting date. That would be the 24th of June, which is John the Baptist's Day and is the most important day in the Masonic calendar. It also happens to be De Vere's death day, and also Edward de Vere and Earl of Oxford both have this 6-to-4 ratio in their number of characters. Let's just, for a game, take the 6th word and then the 2nd word and then the 4th word, and then take the 6th word and the 2nd word and the 4th word. And what we get is these sonnets all by ever-living, well-wishing T. I'm going to ask you to substitute eternal for ever-living, I think that's reasonable, and benevolent for well-wishing. Eternal, benevolent, well, God, obviously. You can't just say it's a Tau cross and that's saintly or godly. These are actually indicative of a gamma, this one in particular. They both are. You know, they don't really have a proper left arm, do they? They're a gamma, which is a G. And we know what G is, don't we? It's a Freemason thing, and it means God. If we now treat these hyphens here as spaces or dots, if you like, in this thing, it's between each dot, then we get a different message. We get the same message at the top, obviously. It's just once these two hyphens come in, we get ever the 4th T. Which is kind of, you know, these sonnets all by ever the 4th T, but I was hoping for Edward de Vere. It's been a bit cheeky there, put a space in there, saying Vere, but yeah, okay, sort of, not really, unless you can put a lot more around it, and we can. If we take this block that it's in and treat that as an anagram, what we've got here is a 15 letter. I know we've got this extra stuff, but we have got a 15 letter telephone number basically here. So we've got G double V. So this is called a double V in the era, and I've set that as 2 V's kerned together. G double V, the poet, and then this is the Vere family motto that had been in use for at least 500 years at the time of printing. This double V, this here is a printed quote from Vere. The little moniker is double V. De Vere, by God, De Vere the poet, Vere O'Neill Verius, the fourth T, and yes, I want to use it as a T now. Duality. Really, you're not using that much of it up here for sure. Well, this is just an overlay, the real puzzle, the real solution. This is just some further corroboration. When you grid the thing, then you get this extremely detailed story. It's not just a message. This is the only instance of this that I'm 100% certain of. The only other one that I believe is there, but we can't prove it yet, is in the funerary monument in All Saints Church, Stratford-upon-Avon. I did quite a bit of work playing around with large dictionaries and modest data sets just to get it. I mean, it converges quite quickly. What you'll find is that even with all of Johnson's dictionary, an ecclesiastical Latin dictionary, and then every place name currently in the UK, all anagrammed, and if you want like the whole of the OED, we can have that in, but we can't anagram it all. Obviously, when you take that kind of dictionary and then you say, right, you can make any grid you like anywhere in lots and lots of text, you're going to find stuff real easy. But what you're not going to find, what then tails off very rapidly, is if you say, I want two things next to each other. These interact. Because of course the words now got to span these, or at least a valid word boundary has to span it. So it puts it under obviously further pressure. And indeed, it's each of these letters here, if they're adjacent like this, and that really starts adding up. And it becomes quite difficult to squeeze these together, if you like. When you take another one, you take a third one, these just aren't turning up, even with ridiculous dictionaries. You have to go through phenomenal amounts of text. This is a heat map of everything that's there. Now, they're not in just verticals, but almost all of it, apart from this huge thing here, a large diagonal spelling Riothersly, almost everything else is in a T shape, connected in symmetrical shape. This is an entropy paradox. You won't find anything like this in plain text. It has to be specially conjured. I've got a few slides now just to wrap this up, and the first is the admission that we've got a bit of a problem here, and that is the existence of a one William Shakespeare actor in the era of William Shakespeare, the author, acting the works of William Shakespeare. It's inconceivable to me that as these works have been debugged, if you like, they've been made to work, that this actor hasn't either indirectly or directly met the author. You've got a straightforward solution to that, but I don't. This is exacerbated by the cryptographic meaning of this. There's a 1740 thing. This V has a geometric value of 20, and then there are 17 characters. That's not the big thing. The big thing is just this name, Shakespeare, because that means Minerva, and that is a core part of our national identity. I've put Minerva Britannia on there just because it says Minerva Britannia, but also along with Wit's Treasury, these two, this by Henry Peacham and this by Francis Mears, really do need to look at Alexander Waugh's presentations. Henry Peacham knew and Francis Mears knew. They're really quite fascinating. What I've been showing you extends considerably beyond here. This one, which accounts for 50% of the post-dating data, I really have to mention because it's all part of the astronomy thing. The other one is a sinking that you have to take the word of a proven liar in order to accept it. So after I've blown this apart, all you've got left is the word of a proven liar. E.K. Chambers in the 1920s, for some reason, decided that this 12th of October 1605 was the relevant eclipse mentioned in Lear. Now, once you're outside those blue lines, nothing's happening. Nobody in Brest here will have seen anything of this eclipse. They will have not been aware of there being an eclipse. We don't have diary accounts from either of these eclipses, and that's quite normal. We have very few diary accounts of eclipses for some reason. We do have tales that were written down some decades later of the chaos in Edinburgh, but what we do have that's significant about the 1598 eclipse is the measurements of Bra and three of his, I believe Bra took three other measurements via Longomontanus, his long-time assistant, and Pedersen, and it's believed also back in Haven, where he made most of his measurements. He was in Hamburg, I think. Moreover, our own John Dee is recorded or reported to have demonstrated this eclipse to the Polish ambassador, and that's quite a stack. I had no idea what E.K. Chambers' Order of the Bath is on, but there's absolutely no contest between these two. I just wanted to stick up for the Freemasons a little bit here. I've been investigating Dryden and his sponsor, John Sheffield. These two were both staunch Tories. Now, Dryden, interestingly, was the first official poet laureate, but our Ben over here is regarded as the first unofficial poet laureate because he was given essentially the same job and paid for it. Now, Sheffield, in view of his behaviour, he actually edited Julius Caesar, lifetime friend of Pope and patron of said John Dryden, who promoted the concept of Britannia heavily and also very much involved with adapting Shakespeare. These two were both staunch supporters of the Stuarts. They were Tories. Sheffield lost his position as Lord Chamberlain upon the Hanoverians, but he still stuck this thing up there. Now, I can't see any kind of geometry. He's quite a distance away from the others. But he is nevertheless in South Transept. He's in the general area. So I don't know what they knew, the people that put this specific monument up. Shoemakers is enrolled to make a nicer bust, presumably, which is paid for by Sheffield's widow. It is said that the Masons came into existence in 1717 as part of a Whig propaganda exercise. They were promoting Whig ideals, the Whigs are the Masons. I can show you people on either side of the political arguments who I can also, with almost certainty, show you that they're surely members of the Freemasons throughout the 18th and 19th centuries. Thomas Babington Macaulay, notable Victorian historian, said of the Veres, the longest and most illustrious line of nobles that England has seen. Now, he's actually contradicting Shakespeare here. He's actually coming out and saying, well, yeah, don't get your history off Shakespeare, because he's missed out in Richard II and Richard III, in both those plays. He's missed out the most important support actor, which was Robert de Vere for Richard II and John de Vere, the 13th Earl of Oxford, in one of the most astonishing military achievements of the era. He scraped up a rebel army and knocked out Howard in the Battle of Bosworth. Macaulay is buried in Poets' Corner. Fancy that. So, who the heck are the Veres? Very quickly, Hastings married William's half-sister, might have gone to Antioch. 12th century established this castle and with the Hospitallers very close with Matilda and establishing the Plantagenets dynasty, including Richard.
in the 13th century, challenged John, a surety of the Magna Carta, wrote the Provisions of Oxford, which are the follow-up, alongside de Montfort, and then fought with de Montfort, and of course lost, but they all got away with it. And then, during the 100 Years' War, with the Black Prince, both Cressy and notably Poitiers, then with Richard II, the Piers Gaveston of the Richard II reign, but get it all back at Agincourt. So that's 100 Years' War. And then in the Wars of the Roses, it starts off extremely badly for them, but they make it back for at least the 5th time that they've lost this earldom and fought to win it back. And Bosworth is turning out to be really quite notable. We've done a lot of research on this over the last 15 years, and we've moved the battle at least a mile to the west, and the role of John de Vere in that battle is accelerating. And then in the Reformation, John de Vere spans from 1540, just after it's happened, all the way up to Elizabeth I, and then appears to have been assassinated, and his young son will spend his life trying to get his inheritance back. There are traditional scholars who believe that Hamlet is, at least to some degree, based on de Vere's life. Apart from the Peasants' Revolt, which did hit Cressing Barnes, which is in the immediate manor of Headingham Castle and the seat of the de Veres, and they would have been very much involved in the suppression of the Peasants' Revolt. That's the whole of English history I just listed off, right up until Elizabeth. So that's where Macaulay was coming from.
Herbert Asquith, who, when he wanted to call himself Earl of Oxford, Cicely Alice Gore, then Lady Salisbury, like a suburban villa calling itself Versailles. Ooh, you're very precious about this, aren't you? So he had to call himself Oxford and Asquith. We had to buy checkers for Asquith. He's our first, if you like, genuinely common Prime Minister. Yorkshire lad. I don't think he spoke with a Yorkshire accent, in fact I'm certain he didn't. He went round the House of Lords allowing people to call him Oxford, just Oxford, which I'm sure he loved, and I'm quite certain Cicely deplored.
Well, we're going to finish here at the Royal Shakespeare Company and the Freemasons' interest in Shakespeare. So on the left we've got Lord Ronald Charles Sutherland Levison Gower, and with a name like that you can imagine he's related to just about everybody. His brother-in-law was the Duke of Westminster, and he was a very senior Freemason, and he laid the foundation stone for this fascinating building, which alas burnt down. There's some of it still incorporated here, burnt down in 1927, and so the Freemasons had it rebuilt. Oliver Russell, 2nd Baron Ampthill, Viceroy of India and President of the Magic Circle, what a CV, laid the foundation stone of this in a very public ceremony, which the British Film Institute can show to you. The Freemasons really do like Shakespeare.
This work is essentially an extension of the work of this man, and I strongly urge you to watch the series of video presentations that he made, which are quite excellent. I didn't know Alexander, but he's the only Oxfordian scholar of note to have shown any interest whatsoever in what I was doing. He did have trouble selling his Cairo, I'd discovered. He was actually wrong with his 30-60-90 in the Abbey. He was perceptive in noting the monuments of Johnson and Drayton are both staring down at the monument, and that was enough for me to know that they won't have been staring down at willy-nilly angles, albeit quite specific ones. And I just hope that he saw at least a little bit of what I was unearthing at the Abbey. I know that he'd seen most of what I'd done on the Sonnets page. If you did know Alexander, can I rather belatedly offer you my sincere condolences?